Hi guys, today we're going to be doing A-level for the mathematics, October-November 2020, paper 3-2. It's a further mechanics paper, so we will start now. For the first question, we have a vertical circle, vertical circular motion. So we have a fixed smooth solid sphere of center O and radius A. A particle of mass m is projected downwards with speed set 1/6 ag from the point A, where OA makes an angle alpha with the upward vertical through O. Particle moves in part of a vertical circle on the surface of the sphere. It loses contact with the sphere at point B, where OB makes an angle beta with the upward vertical through O. So let's assume that this is B, this is point B, oops, point B, and it makes an angle beta with the upward vertical. Okay, so given that cos alpha is 2/3, find the value of cos beta. So we know that for vertical circular motion, we first need to draw out the forces on the mass itself. So we have, this is mg, and we need to resolve it in the direction towards the center and tangent to the circle. So as we know that this angle is alpha, so now we have this angle as alpha too, right? So the force towards the center of the circle would be mg cos alpha, and for for the force that is tangent to the circle, it will be mg sine alpha. And don't forget about the contact force. So the contact force would be directly perpendicular from the surface. So this is the surface, right? So perpendicular away from the surface. This would be our contact force at A. Let's call it RA for now. Alright. So at B, similarly, we have our weight, mg, and we need to resolve it in this direction and this direction, right? So for point B, this angle would be beta, and therefore the force towards the center of circle would be mg sine beta. And for the force that is tangent to the circle, it will be mg, sorry, this is cos beta, and this would be mg sine beta. And according to the question, it loses contact when the sphere is at point B. So there will be no contact force at point B. Alright? So now we can start doing the steps. we can use the principle of conservation of energy. So we have the kinetic energy gain equals to the gravitational potential energy loss. So for kinetic energy, the change in the kinetic energy is half m times the change in v squared. And for GPE, we have mgh, where h is the difference in the height. So we have half m. For the change in v squared, we know that initially we have a speed of cert 1 over 6 ag, right? And the final speed at b is unknown. So, but we know that it moves downwards. That means this speed would be higher than this. So we use the speed at b, which is vb squared, minus the speed at a, which is the square of cert 1 over 6 ag. And for the GPE, we have mg height would be this height over here that we have to find. So this whole thing would be a cos alpha, right? Because this line over here is a. Similarly, this line over here is also a. So we have this height as a cos beta. So now the height difference would be a cos alpha minus a cos beta. So now we can simplify the equation. Can cancel off the m, and now we will have half of vb squared minus 1 over 12 ag equal to ag times 2 over 3, cos alpha is 2 over 3 given here, and minus ag cos beta. Cos beta will be the unknown that we have to find. Alright? So let's make vb squared our subject. So we have half of vb squared equal to 3 over 4 ag minus ag cos beta, and hence vb squared is equal to 3 over 2 ag minus 2 ag cos beta. And now, since vb squared is still an unknown, we need to use another equation to get rid of this unknown over here. So we can use the fact that the centripetal force is always the resultant force, or the net force. So the formula for centripetal force would be mv squared over r, right? And in this case, we want to find the centripetal force in B. So the v squared would be replaced by vb squared. So the net force at B, let's look back at the diagram. The net force at B towards the center of circle is just mg cos beta, because there's no contact force over here, right? So the net force is just mg cos beta. So now we can sub this equation into the VB square over here. So we have, okay, first we can cancel off the m, so it's not that confusing. And now we have 3 over 2 ag minus 2 ag cos beta over the radius of the circle is a, equal to g cos beta. Alright, now we can cancel off the a and g. So a, g, g, g. So now we have 3 over 2 minus 2 cos beta equal to cos beta. So 3 cos beta equal to 3 over 2, and cos beta is just 1 over 2. And that's it. For question 2, we have two uniform smooth spheres A and B of equal radii, and A have mass of 2m and B has mass of m. Sphere B is at rest, so the initial speed of B is equal to 0. So it's at rest on a smooth horizontal surface. Sphere A is moving on the surface with speed of u and collides with B. Immediately before the collision, the direction of motion of A makes an angle alpha with the line of spheres of the centers of the sphere, where tangent alpha equals to 4 over 3. The coefficient of restitution between the spheres is 1 over 3, so this will be our E. Find the speed of A after the collision. Okay, so we can use two equations, one being the law of restitution, which is VA minus VB equals to negative E times UA minus UB. Another one is the principle of conservation of momentum, which is the mass of A times VA plus MB times VB equal to MA times UA plus MB times UB. So let's look at the first equation first. We have VA as our unknown and VB is also our unknown, minus 1 over 3 times. Okay, so in these two situations, we only look at the velocity in the direction of the centers of the spheres. So only in this direction. So now we need to resolve this in this direction. Let's call it the horizontal direction. So we know that this is u and this is alpha. So this would be u cos alpha. So we have ua equal to u cos alpha, and ub is 0 from this fact here. So we have VA minus VB equal to negative 1 over 3 times U times cos alpha would be, alright, let's not change this first. Let's maintain this as U cos alpha. Okay, so now this will be our first equation. And let's look at this equation here. Mass of A is 2m, VA is still VA, plus mass of B is m, VB is still VB, equal to 2m times u cos alpha plus 0. So we can cancel out the m's. So now we have 2va plus vb equal to 2u cos alpha. This would be our second equation. So now we can take the first equation plus the second equation to get 3va. Vb is already cancelled out because minus and plus is cancelled out. So 3va equal to 5 over 3u cos alpha. And va would be equal to 5 over 9 u cos alpha. And according to this question, tangent alpha is 4 over 3. So imagine we have a right angle triangle with alpha as this angle. Tangent is opposite over adjacent. So we have 4 over 3. This will be our ratio. So now our hypotenuse would be 5. So now cos alpha would be 3 over 5. So we have VA as 5 over 9 times 3 over 5u. So we would get 1 over 3u as our VA. So now we need to find the speed of A because VA is just the velocity in this direction. So we know that the velocity, keep in mind that the velocity that is perpendicular to the centers of spheres, which is in this direction, is always unchanged after the collision. So when we resolve this in the vertical direction, let's call it, we know that this is alpha. So in this direction, this would be u sine alpha. Alright? So the vertical velocity would be u sine alpha. And sine alpha is 4 over 5, right? 4 over 5. So it would be 4 over 5u. So now the speed is simply just the square of 1 over 3u plus the square of 4 over 5u and square root the whole thing. So we would get 13 over 15u as our speed. Question 3. An object consists of a uniform solid circular cone of vertical height 4r and radius 3r, and a uniform solid cylinder of height 4r and radius 3r. The circular base of the cone and one of the circular faces of the cylinder are joined together so that they coincide. The cone and the cylinder are made of the same material. So we have a cone and a cylinder that coincide. Find the distance of the center of mass of the object from the end of the cylinder that is not attached to the cone. So from the base basically. So now we look at this object from the front view. So if we look at the front view, all we see is a triangle and a rectangle. Okay? So this triangle has height of 4r And the rectangle also has a height of 4r. And their radius is 3r, so this would be 3r. I know the base is supposed to look longer, maybe something like this, I guess. But it's okay, it doesn't really matter. Okay, so now we have to find the center of mass from the base. So this is the base. Alright. Now we can draw a table. So the first column, we have the solid. That is, first is the cone, second is the cylinder. And they add up to become a so-called object according to the question. So let's just call it an object. And the second column, we have the volume. Third column, we have the distance of center of mass from the end of the cylinder that is not attached to the cone. Let's call it the base. Okay, so now for volume of cone. The volume of cone is basically 1/3 of the volume of cylinder. So 1/3 times pi r square h. And this would give us 12 pi r cubed. And for the volume of cylinder, we have pi r h. So this would give us 36 pi r cubed. So both of these add together, what we get is 48 pi r cubed. So the entire object, this entire object, has a volume of 48 pi r cubed. And for the distance of COM from the base, we first look at the cone. So according to the formula booklet, if we have a solid cone, the center of mass is 3/4h from the vertex. That means if this is the center of mass of the cone, the distance from the vertex all the way to the center of mass is 3/4 of the height, which is 3r, right? So now we look at the distance of this center of mass from the base. So this is 4r and this is 1r, right? So add together, we have 5r. So we can write 1/4 times the height of the cone plus the height of the cylinder, which is 4r. So we have 5r over here. And for the COM for the cylinder, it's easy, it's just right in the middle, right? So this is 4r, this will be 2r, this would be 2r. So the distance here is just 2r. And for the center of mass of the object is the thing that we need to find, right? Let's call it y bar. So how do we find for y bar? We just take the volume of cone, which is 12 pi r cubed, times the distance of COM for the cone, which is 5r, plus volume of cylinder, 36 pi r cubed, times the distance of COM for cylinder, which is 2r. And then we divide it by the volume of the object, which is 48 pi r cubed. So we get 11/4 r. Part B. show that the object can rest in equilibrium with the curved surface of the cone in contact with a horizontal surface. That means we have our object, oh my god, we have our object like this, but now we have to let it rest with the curved surface on the horizontal surface. So let's tilt it like this. Yeah, sure. Let's just put it here. So we have the object like this. Let's say, so we know that the distance of COM from the base is 11 over 4r. That means this is around here maybe. This is definitely still in the cylinder. So we have the COM, let's say it's over here. And now we need to find whether, no, we need to prove that it can rest like this. So what we do is, we just have to prove that the COM is still within this curved surface. As long as it's not somewhere that is that past this line, then we are good to go. So how do we do it? Let's draw a few lines. First, we connect this to the vertex of the cone, and then we draw a dotted line over here. Okay? And now we need to find this angle over here. So we know that what is this distance over here? We know that this whole thing adds up to 8r, and this distance over here is 11 over 4r. So the distance over here is simply just 8r minus 11 over 4r, which gives us 21 over 4r, right? And we have to find this distance, we just need this angle over here. So how do we find this angle? We see that this is also a right angle triangle, right? So let's use another color. This distance, oops, this distance over here is 3r, and this over here is 4r. So what is the angle over there? It's tangent theta equals to 3r over 4r. So tangent theta is just 3 over 4. So now we know the angle in terms of tangent. We can use the fact that tangent equals to 3 over 4 to find for this distance over here. So to use this, to find for this, we need to use cos theta, right? So tangent theta is 3 over 4. That means we have a right angle triangle. Imagine this is our theta. So 3 over 4 is opposite over adjacent. This is the ratio. So the hypotenuse would be 5. So cos theta is 4 over 5. And let's call this distance x. Let's call this x. So now x would be the distance over here, which is 21 over 4r, times cos theta, which is 4 over 5. So this would give us 21 over 5r. So since the curved surface is 5r, we know that 21 over 5r has not exceeded the curved surface, the length of the curved surface, right? So we can say that the curved surface of the cone is 5r, and that 21 over 5r is less than 5r. Hence, the center of mass is above the curved surface when it is in contact with the horizontal surface. Done. Question 4. A particle P of mass m is moving in a horizontal circle with angular speed omega on the smooth inner surface of a hemispherical shell of radius r. So we have omega and r. The angle between the vertical and the normal reaction of the surface on P is theta. So we have a bowl-like structure, a hemisphere basically, and this would be the center of the hemisphere. I mean, it will be the center of the sphere if it's a sphere. And let's say we have our particle P over here, then this would be the horizontal circle that is moving, right? So now we have a vertical that passes through the center of the sphere, and we know that the angle between the vertical and the normal reaction of the surface on P is theta. So the normal reaction would definitely be towards the center of the sphere. Because all the curved surface, this is the curved surface, right? It has a tangent like this, and this would be the perpendicular to the tangent, alright? So this would be our normal reaction. Let's call it R. And this angle over here is theta. Okay? So now for part A, we need to show that cos theta equals to g over omega square r. So we know that the radius of the hemispherical shell is r. That means this would be r. This length will also be r. But what is the radius? What is the radius of our circular motion? This one is definitely not equal to this, right? So let's draw a line over here. So since this is theta, this is r, so our radius of the circular motion would be r sine theta, right? Okay, so now we use the information that we have to prove this. We know that the particle has a weight of mg, and but the centripetal force would be towards the direction of the center of the circular motion, right? Because the circular motion is a horizontal one, this would be the center of the circular motion, not this, alright? Here. And this is horizontal, but this is vertical. So weight definitely has no effect on the centripetal force. Instead, our normal reaction has the effect on the centripetal force. So we can resolve the normal reaction over here in the vertical and horizontal direction. So we can write this. Okay, this is also theta, right? Because it's an alternative angle, right? So this we can write as r cos theta, and for the horizontal direction we have r sine theta. So now we can erase this. So from all this information, we know that the vertical forces definitely will be equal to each other. So we have r cos theta equal to mg. And let's make r the subject. So we have r equal to mg over cos theta. And for the horizontal direction, we know that the centripetal force is equal to m times the radius. Let's write the radius instead of just r, because we'll be confused after that. M times radius times omega squared. So now we know that the centripetal force is just r sine theta. So m is still m. Radius of the circular motion, like what we said just now, is r sine theta. So we have r sine theta times omega squared. And we can cancel out the sine, and r would just be mr omega squared. So we swap this r into this, and we would get mg over cos theta equal to mr omega squared. So we cancel out the m's and make cos theta the subject. So cos theta is equal to g over r omega squared. Oh, the question wants omega square r, so sure, let's put it that way. And we are done. Part B. The plane of the circular motion is at a height x above the lowest point of the shell. When the angular speed is doubled, so when it becomes 2 omega, the plane of the motion is at a height 4x above the lowest point of the shell. So now, this whole thing, let's copy it. Erase all the unnecessary things. Okay, so this is our original situation, and now we have another situation that is our particle has moved up. So around here, we have a similar situation. Okay, so this is still r, right? The radius of the sphere would not change. So it says that originally this height is x, and now this height is 4x, and our angular speed has been doubled. So since our angular speed is doubled, obviously the normal reaction will also be doubled, right? So we cannot use the previous information, but we can use this equation over here. We can use the equation that we just proved just now. Because we cancel out the r, that means it doesn't have an effect. But what we need to do is we need to change our omega and the angle over here. Because the angle over here is definitely not the same. Let's call it alpha now. It's definitely not the same as the previous one. So since this whole thing is r, right? And this is x. So this would be r minus x. This length right here. And similarly, this is just r minus 4x. So let's look at the first situation first. In the first situation, we can use this again, but we need to sub cos theta as something else. So cos theta, we can now write it as r minus x over r. So r minus x over r equal to g over omega square r. And in the second situation, this one, we can write cos alpha equal to g over, okay, now we have to sub omega as 2 omega. So it's not 2 omega square, but instead it's bracket 2 omega square the whole bracket times r. So cos alpha, similarly we have r minus 4x over r, right? And on the right hand side we have g over 4 omega square r. So now we can see that okay, we can cancel the r on the denominator out, and we can write this as g over omega square equal to r minus x, right? And for the second situation, we can also write g over omega square as four r yeah 4r minus 16x, because we move the 4 to this side, so we just multiply this whole thing by 4. So now we get two values of g over omega square. So now we can equate them. So r minus x equal to 4r minus 16x. So simplify this, we need to make x the subject. So we have 15x equal to 3r, and x is equal to 1 over 5r. That's it. Question 5. We have a particle P that is projected with speed u at an angle of theta above the horizontal from a point O, and it moves freely under gravity. The horizontal and vertical displacements at time t are denoted by x and y respectively. Starting from the equation of the trajectory given in the list of formula, MF19, show that this equation is true. So we go to the MF19, we can see that this is the formula given. Copy it, paste it here. Okay. So we can actually just start from this. We don't have to prove this formula to use it. So we have y equal to x tangent theta minus gx squared over, see, the v square here is actually the initial speed. But in this question, the initial speed is given as u. So we need to change that to 2u squared cos square theta. Alright? So now the question wants it to be in this form, 1 plus tangent square theta. So we should first change this to secant square theta, right? 1 over cos square theta is secant square theta. So we have x tangent theta minus gx squared over 2u squared secant square theta. So this can be written as 1 plus tangent square. So now we have x tangent theta minus gx squared over 2u squared times 1 plus tangent square theta. That's it. Question B. When theta equals to arctangent 2, P passes through the point with coordinates tan 16. So this means that when tangent theta equals to 2, it goes through tan 16, means x equals to 10 and y equals to 16. Show that there is no value of theta for which P can pass through the point with coordinates 18, 30. So we can use back this equation that we just proved. I'll paste it over here. So now we can see that there is a constant g over 2u squared, right? And we need to find this constant using this information given. So we can sub all of this in. So y is 16. So 16 equal to 10 times 2 minus g times 10 squared over 2u squared times 1 plus 2 squared. So we simplify it and we would get 250g over u squared equal to 4. So g over u squared is equal to 2 over 125. So this is the constant that we find. And now we sub it back to find whether we can get this. So how do we do it? We can see whether we can prove that there is no value of theta. So we sub it back. 30 equal to 18 times tangent theta minus 2 over 125 times 18 square. Oh, sorry, half of this because there's a 2 there, right? So half of 2 over 125 times 18 square times 1 plus tangent square theta. So simplify it, we get 324 over 125 tangent square minus 18 tangent plus 4074 over 125 equal to 0. Simplify this. This looks a bit messy. Let's times it by 125 over 6. So we would get 54 tangent square minus 375 tangent plus 679 equal to 0. So what we do now is we just prove that there is no solution for tangent theta, and hence there's no solution for theta. So how do we do it? We use the discriminant. B squared minus 4ac is equal to negative 375 squared minus 4 times 54 times 679. This would give us negative 6039. So b squared minus 4ac is less than 0. Hence, there is no real solution for theta when P passes through point 1830. Done. Question 6. One end of a light elastic string of natural length A, so this is natural length, and modulus of elasticity K is attached to a particle of mass m. The other end of the string is attached to a fixed point O. It is projected vertically upwards from Q. When P is moving upwards at a distance 4 over 3a directly above Q, it has a speed set 2ga. At this point, its acceleration is 7 over 3g downwards. So we need to show that k equals to 4mg and find in terms of a the greatest height above q reached by p. So let's do the first part first. To find for k, we can use resultant force equals to ma since we have the information about the acceleration, right? So when it is at this point, its acceleration is 7 over 3g downwards. So that means the net force is going downwards as well, right? So the downward force would only be, okay, let me draw it. So it is attached here, the ball is here, the particle is here, and there's the elastic string. So we have the weight downwards, mg, and because this elastic string is stretched, that means the tension force is also downwards because it is stretched. The distance is 4 over 3a and the natural length is a. That means there is some elastic potential energy. So it is stretched, there's tension. So now we know that the net force downwards is mg plus tension, which is modulus of elasticity, k, times the extension, 1 over 3a over the natural length, which is a, equal to okay, the a here is the acceleration, so it's 7 over 3g. So we can cancel this, and we have 1 over 3k equal to 4 over 3 mg. So k would be 4 mg. So we have proven the first part. Second part, we need to find the greatest height. So to find for the greatest height, we can actually use the principle of conservation of energy. But first, we would need to find the initial speed. So when it is projected vertically upwards, what is the initial speed? So we can actually use back the same situation where when it is 4 over 3a directly above q, it has a speed set 2ga. We can use this two info to find for our initial speed. So it would be the gravitational potential energy gain plus the elastic potential energy gain equal to the kinetic energy loss. So GP is mgh, so mgh would be 4 over 3a, right? This height over here is 4 over 3a plus our modulus of elasticity, we have found it just now, 4 mg times the square of extension, which is 1 over 3a square, over 2 times our natural length, so 2a, and equal to the kinetic energy loss. So for the kinetic energy loss, we need half m times the change in v square. That means the initial speed square minus the final speed square. So initial speed, let's call it u. So u square minus the final speed, which is the square of set 2ga. So simplify everything. We have 4 over 3 mga plus 2 over 9 mga equal to half mu square minus mga. So half mu square equal to 23 over 9 mga, and u square is equal to 46 over 9 ga. So now we have found the initial speed square, and we can start finding for the maximum height or the greatest height. So for the greatest height, we have our particle here. This is, sorry. So let's say this is the natural length, a. This whole thing, we call it h, the greatest height. Okay, so this part would be h minus a, right? And what is h minus a? Is basically the extension of the extensible string. So we have our GPE gain plus EPE gain equal to the KE loss. So GPE gain would be same thing, mgh plus the elastic potential energy is actually 4 mg times h minus a squared over 2a. Like what I said, the extension is actually this part, so h minus a. And for the kinetic energy loss, it's just half m times the initial speed square, which is 46 over 9 GA. See, this is already squared, so we don't have to square it anymore. Okay. Why do we not need to minus anything over here? Why do we not need to like minus the final speed squared? Because when it reaches its greatest height means it's not going upwards anymore. It stops going upwards, and after reaching the greatest height, it will start falling. So at that split second, it's actually not moving, and hence the speed is actually 0. So now we continue doing this. So cancel out the m's, too many terms here. So we have gh plus 2g times h minus a squared over a equal to 23 over 9 GA. And to get rid of this, let's multiply the whole equation by a. So we have GAH plus 2G times h squared minus 2AH plus a squared equal to 23 over 9 GA squared. So now we can cancel out the g's. And AH plus 2h squared minus 4AH plus 2a squared is equal to 23 over 9a squared. Rearrange it, and we would get 2h squared minus 3ah minus 5 over 9a squared equal to 0. We can change it to 18h squared minus 27ah minus 5a squared equals to 0. This is just by multiplying the equation by 9. So now we factorize it, we find that 3h minus 5a and 6h plus a is actually the factor of that equation. So h is 5 over 3a, or h is negative 1 over 6a, which is ridiculous. So we reject this. We want the maximum height. This is actually when the particle is 1 over 6a below this point. So we don't want that. Okay, so we're done for this question. Question 7. A particle P of mass m moves in a horizontal straight line against a resistive force of magnitude mkv squared, where v is the speed after it has moved a distance x and k is a positive constant. The initial speed of P is u. Show that x equal to 1 over k ln 2 when v equal to half u. So we first need to build our own equation. So let's say a particle is moving towards the right. It has a resistive force in this direction, that is mkv squared. So we use the resultant force equal to ma formula. So resultant force is just negative mkv squared. Why is it negative? Because it's in the opposite direction of where the particle is traveling to. So equal to m times acceleration can be written in terms of v times dv over dx. So cancel out the m. We get negative kv squared equal to v times dv over dx. So we can start moving the dv and dx. So we have, on the left side, we have negative k times the integration of 1 dx. And on the right side, we have the integration of 1 over v times dv. So we can integrate both of them. So we get negative kx equal to ln v plus c. C is just a constant that we have to find. So how do we find that constant? Is that we know that the initial speed of p is u. So that means when x equals to 0, v would be equal to u. So v equals to u when x equals to 0. So 0 equals to ln u plus c. C is equal to negative ln u. So now we have to show that x equal to 1 over k ln 2 when v is equal to half u. Let's write the equation in terms of x first. We have negative kx equals to ln v minus ln u. So x would be equal to 1 over k ln u minus 1 over k ln ln v. So when v equals to 1 over 2u, x is equal to 1 over k ln u minus 1 over k ln half u. So the terms in front is the same. We can take 1 over k ln u over half u. And this would give us 1 over k ln 2. Done. Part B. Beginning at the instant where the speed of p is half u, an additional force acts on p. This force has magnitude 5m over v and acts in the direction of increasing x. Show that when the speed of p has increased again to u, the total distance traveled by p is given by an expression of the form 1 over 3k ln a minus ku cubed over b minus ku cubed, stating the values of the constants a and b. So this is another situation, and we can treat it as a new thing. We disregard everything that we did in front and we treat it as a new thing. So the particle is here, goes in this direction, increasing x, and now we have an additional force that is acting on p. So this has magnitude 5m over v. And don't forget about our resistance force. Our resistance force according to the question just now, is mkv square. mkv square. So now that the speed of p is half u, so the speed now, the starting speed is half u. And we need to find the distance traveled when the speed is increased to u again. But we need another equation because now we have an additional force here, right? So we make another equation. So 5m over v minus mkv squared, this is the force, the resultant force, equals to m times acceleration, which can be written as v times dv over dx. So cancel out the m's, and we get 5 over v minus kv squared equal to v times dv over dx. To get rid of this, we can times the whole equation by v. So we have 5 minus kv cubed equal to v squared times dv dx. And we need to separate the dv dx, so we get the integration of 1 times dx equal to the integration of v squared over 5 minus kv cubed times dv. So we can integrate both of them. So we get x equal to, okay, so for this, we know that the differentiation of this term is actually negative 3k v squared, right? And the numerator already has v squared inside, so we just need to add a negative 3k inside. So we can add a negative 3k inside so that the numerator is the integration of the denominator. But to add this, we need to divide it on the outside so that the original expression is not changed, right? So it will be negative 1 over 3k times ln 5 minus kv cubed plus a constant. To find the constant, we know that now this is a new thing, right? So we assume that this is the starting point. So x is equals to 0 over here. So when x equals to 0, v equals to half u, right? So 0 equal to negative 1 over 3k times ln 5 minus k times 1 over 2u cubed plus c. So c would be equal to 1 over 3k ln 5 minus 1 over 8 ku cubed. We rewrite the equation in terms of x to make our life easier. So x is equal to negative 1 over 3k ln 5 minus kv cubed plus the constant, which is 1 over 3k ln 5 minus 1 over 8 ku cubed. And we can simplify this. So we have 1 over 3k times ln 5 minus 1 over 8 ku cubed over 5 minus kv cubed. And simplify this again, because we don't want to see fractions on fraction, right? So 1 over 3k times ln we times 8 on both the numerator and the denominator, so we get 40 minus ku cubed over 40 minus 8kv cubed. So now we have the equation for x, and we find for the distance traveled on the second half when when v equals to u. So when v is equal to u, x will be equal to 1 over 3k ln 40 minus ku cubed over 40 minus 8 ku cubed. So, but the question wants the total distance traveled, right? The total distance traveled by p. So now we have to add this and this together. Alright, we need the total distance traveled on the first part and the second part. So the total distance is 1 over k ln 2 plus 1 over 3k ln 40 minus ku cubed over 40 minus 8 ku cubed. And the question wants a single term, so we need to find ways to combine it. And to combine it, the fraction in front, or the term in front here, should be the same. The coefficient should be the same. So what we do is we change this into 3k as well. So we have 1 over 3k times 3 ln 2 plus 1 over 3k times ln 40 minus ku cubed over 40 minus 8 ku cubed. And 3 ln 2 is basically ln 2 cubed, which is ln 8. So we have this. Okay, now we can finally combine both of them. So we just take 8 times this term over here, and we would get 1 over 3k ln 40 minus ku cubed over 5 minus ku cubed. And we are done. It's exactly like what the question wants. So A would be 40 and B would be 5.